Hello, this is Mike. Today we're going to do another validation. Hoping to make this a nice quick one. I'm not going to spend a whole lot of time explaining different functions of the program today. We're just really looking to add to our library of models that are giving us validated results with the Inventor Nastran program. So as far as the description is concerned, it is a cylinder with an outside radius of 10 inch, inside radius is 5 inch. We're going to apply an external pressure of 50 psi. The model is 13 inches tall as I have it built, and we're going to take a look at the radial displacement and the stress tensor. I did build my circles in the XZ plane, and then I extruded in the Y direction. So when we take a look at the interrogation of the stresses in the hoop or circumferential direction, we're going to take a look at the Z stress tensor, right? So that would be normal to this face. So if we inquire on a result right here at the corner of the model, then we can get our stress tensor as well as our radial displacement. If I use that same quarter, that would be an X direction displacement. So let's go ahead and set this up and see what we get. So I'm going to go environments and we'll go into the Inventor Nastran program. I do need to define my material. So we'll edit the material here. I'm going to do a select material. I'm going to start with something out of the Autodesk material library, like the steel ASTM A36, and then we'll just modify it as need be. So I'm going to just change the modulus of elasticity, 3E7 or 30E6, same thing. Poisson's ratio at 0.3 is good. We'll say okay. So let's do constraints next. And this is a symmetry face for Z. So we'll do Z symmetry and we'll give it a name. Select that surface and say okay. Constraint on this face, perpendicular to that is the X, so that's X symmetry. Give it a name. You don't have to do the naming part. I just, as people who have watched my videos might know, I just like to end up in the model tree so it's nice and clean. Bottom surface here, Y symmetry. And again, give it a name. There we go. So there's our three symmetry faces. That's all we need for constraints. I'm going to select the back surface here. We'll do a load, and that is a pressure, and the pressure is 50 psi. So let's go ahead and generate the mesh on that. There we go. If you don't like the color of the mesh that it gives you, you can always go here and change the color. I'm okay with that there. Let's add some refinement since we're going to interrogate results on this surface. I'm going to do a little bit finer of a mesh, maybe a lot finer of a mesh there. So I'm going to go into mesh control and we'll use face, select that face, and let's make it about 0.25. Say okay. And when we add that refinement, does add itself, or mesh control does add itself to the model tree there if you need to edit it. We do need to generate the mesh again, of course. There we go, much finer mesh, so that should do us just well. Let's go ahead and run the simulation, and then we can interrogate the results. So it should be a pretty quick run here. There we go. And that's a really exaggerated display shape. So let's right click on the result here. We'll say edit. And the form options, let's set it to actual. There we go. Let's check our displacements first. Displacement, and we want a radial displacement. So for this corner, I'm going to say along the x-axis. All right, and then what we can do is do a query. Right click on nodes and query display, and that gives me a value in x of 0.000022. So let's go ahead and type that in, minus, just to keep the units consistent, 0. There's 400, 0.000022, and we'll hit enter. So that gives us, that really could be round off there, but we'll take it, less than 1% difference there in the results. And then we're going to take a look at stress. And again, we want a hoop or circumferential, right? So in that case, we want to take a look at, for this node on this face, we want to take a look at the z direction. So z normal. And if I select that same query point there, that gives us a value of a minus 133. So if I put that in at minus 133, hit enter, our percent difference is 0.2. So really couldn't ask for much better than that. So hopefully that helps, and hopefully you learned something today. Thanks for watching. You have a great day. Take care.